Assalamualaikum warahmatullahi wabarakatuh. We are from Group 12 representing our task, which the title is How to Evaluate the Effectiveness of Antimicrobial Agents. My name is Akmariza bin Azri. My matric number is F21A1048. The introduction. Agents that kill or inhibit microorganisms may be classified as disinfectants, antiseptic, or antibiotics. Antibiotics are molecules that are produced by one microorganism that kill bactericidal or inhibit bacteriostatic other microorganisms. Antiseptic and disinfectant are commercially prepared chemical, and distinction between them is the antiseptic can be exposed to mucosal surface for at least a short time, and disinfectant should not, as they could impact harm. Antimicrobial susceptibility testing can be used for drug discovery, epidemiology, prediction of therapeutic outcome. Antiseptic and antibiotic assay can be performed in much the same way. Finding the minimal inhibitory concentration, the lowest concentration that stop growth of the test organism is MIC. By measuring the zone inhibition produced by inhibiting growth of a launch of test organism to do a MIC, the antiseptic or antibiotic is firstly serially diluted, and then each dilution is mixed with a standard inoculum of the test organism. After growth in the control, usually 18 to 24 hours at 37 degrees Celsius, the tubes are examined for the presence or absence of growth.
Okay, first of all, my name is Dini Ali Baikal bin Abdul Khairul. The size of the zone of inhibition is dependent on the concentration of the test substance, its potency, and the rate of diffusion in the medium. Most antiseptic and antibiotic are small molecules and have identical diffusion rates. The zone of inhibition is a good measure of the effectiveness of the test substance against organism, especially in pairwise comparison where the concentration of the test substance are nearly identical. Other distribution methods can be used to test the evaluate of the antimicrobial agents. Okay, as we know, in a lab, we must to prepare all the materials and equipments before we start our experiment. Okay, let's see the slide. All materials we need to prepare in this experiment. Antiseptics commercial wet wash, 1 liter agar plate, micropipettes, sterile cotton swab, paraffin, forceps, sterile paper dish, bacteria culture, for example, Escherichia coli, antibacterial agent, chloramphenicol, sterile water, and more. Okay, after that we continue our procedure on this experiment. For step 1, before you start the experiment, swab the bench with 70% ethanol before you start the experiment. Then use the spark lighter to light the Bunsen burner.
Assalamualaikum. My name is Muhammad Hafiz bin Abdul Wahid. Number matrix F21A1134. Okay. Step 2. Preparing dilution. You have to prepare 5% and 50% of the mouthwash. Final volume is 2 ml. Use sterile distilled water as the diluent. Label the test tube with the mouthwash concentration that you want to prepare. Using micropipette, transfer the appropriate volume of diluent SDW into the labeled test tubes. Then transfer appropriate volume of mouthwash into the tubes containing the SDW. Then close the test tube cap and mix the solution. Okay, step 3, preparing control plate. First, label the bottom of an A plate with your name, date, and experiment name. Label at the edge, not in the middle. After that, use a cotton swab and dip into the E. coli brood culture. Then remove excess water so that your plate is not wet. After that, swab the Na thoroughly with the E. coli. Do it near the ileum to prevent contamination. Then, using a forceps, take one sterile paper dish and wet with 10 UL of positive control, chloramphenicol. After that, transfer the dish on the swab Na plate. After that, this should be placed in the middle so that easy to measure the inhibition zone.
Assalamualaikum and good night. My name is Muhammad Ikram bin Sabuddin. Matrix number F21A 11116. First of all, you should use a cotton swab and swab in your mouth. Next, place the swab into the liquid media. After that, label the tube with your name and date. It's marked for your experiment. And next, incubate the swab culture at 37 degrees Celsius for at least 2 hours. In this part, longer incubation is recommended lah. After incubation, use the cultures for antimicrobial assay and then label the bottom of any plate with your name, date, and experiment name. After that, divide the plate into three, which is ND 5% and 50%, and mark the dish on the back of the plate. But first, make sure the inner plate is dry. And next, remove condensation with water by tapping the petri dish lid. Then, take out the cotton swab from mouth bacterial culture and use it to swab the inner plate. After done swab the inner plate, do it near the flame to prevent contamination, to prevent to from other things. Then, using forceps, take one sterile paper dish and wet with 10 microliter of each mouthwash concentration, which is ND 5% and 50%. Next, transfer the dish onto the swab inner plate. And lastly, incubate the assay plate at 37 degrees Celsius for 24 until 48 hours with a daily observation. That's all. Thank you.
Step 5. Result analysis. In this step, we will analyze the radius of inhibition zones using a ruler to get the measurement of the zones. To measure the zones, put the ruler directly across the zones of inhibition from edge to edge, crossing through the center of the dish. But if your plate has uneven inhibition zone, measure it from the center of the dish to the edge of area with zero growth. The measurement should be in millimeters, and to get the diameter, we will multiply it by 2. So, the diameter of the zone of inhibition measured in millimeters and compared to a standardized chart to determine the susceptibility of or resistance of the bacterial pathogen to the drug. Next slide. This is an example of the result, and you can see some of the inhibition zones in the petri dish. Next slide. For the conclusion, antibiogram provides qualitative results by categorizing bacteria as susceptible, intermediate, or resistant. Therefore, it is a typing tool based on the resistance phenotype of the microbial strain test. Its outcome also guide clinicians in the appropriate selection of initial empiric treatments and antibiotic use for individual patients in particular situation. However, since the bacterial growth inhibition does not mean the bacterial death, this method cannot distinguish bactericidal and bacteriostatic effects.